Okay, good evening, people. For the last time.
गुड इवनिंग सर।
गुड इवनिंग सर।
Okay.
ऐसा मत बोलो सर।
गुड इवनिंग गुरुजी।
मतलब इवनिंग तो पूरा रहेगा इसके बाद में, but you won't be able to hear this from me in a live class. So
यस सर।
so that
सर रिकॉर्डिंग चलेंगे।
अरे अभी रिकॉर्ड कर लेना, काम कर गुड इवनिंग बोल रहा हूं, एक बार सुन ले।
रिकॉर्डिंग करने की कोशिश करी पर आवाज नहीं जाती सर। आती
अरे
ऑलरेडी है।
अरे दूसरे फोन से ले ले, इसको लाउड स्पीकर पे रखते हैं, दूसरे फोन से ले ले। क्या यार, कोई नहीं, चलो
ये की फोन है।
ओके, समथिंग इन द चैट, सर वी आर गोना मिस यू। अरे सेम हियर, देखो ना, स्माइल आई नहीं रही है मेरी।
सर आपको मैंने इंस्टाग्राम फ्रेंड रिक्वेस्ट भेजी है।
अच्छा इंस्टाग्राम पे ठीक है, कोई नहीं, देख लेंगे। सो let's complete our syllabus and the chapter and the subject and everything. Let's get started, people. Last topic that is remaining, our chapter of applications of Schrodinger equation, and that is hydrogen atom. देखो, हम hydrogen atom people we have already learned in SCTQ, but that was different. Before classical to quantum, we had learned like in that we had learned energy, kinetic energy, potential energy, binding energy, Lyman series, Barbour series, all of that. That was different. So now what we have to learn is the wave function attached to a hydrogen atom, people, like to any particle. Like for example, if you take a hydrogen nuclei, helium nuclei, anybody, any hydrogen-like atom, then what is the wave function attached to them? Because like we know, people, these electrons and things, any particle can behave as a wave. Even if you remember, there is a theory by Steve Broglie himself that all the matter can be associated with a wave, and we call it a matter wave. So when we have a wave, just like our wave is negligible. We have also calculated the wavelength of our wave, people. It's very negligible, and hence we don't show interference patterns, people, when we are walking around. But no worries. Sir, there is no second lecture today. I know, Akash, there is no second lecture today. But I was being informed, but I was like, there is no, and I will extend the lecture unnecessarily, so I don't need the second lecture today. But the best part is, since there is no second lecture, after completing this topic, we can converse for some time. So at least I will not be in a rush today. So that's good. Okay, but yes, there is no second lecture today, so that's good. Anyway, so what do we recall related to hydrogen atom? Energy of hydrogen atom, if you remember, that was me raised to 4, the whole upon 8 n square h square epsilon naught square, correct, into z square. This was the whole formula of energy. You, if you are not by heart this, you are supposed to by heart this formula too. You may just remember minus 13.6 upon n square all the time. That's fine. But this was the original formula. And in this, as we clearly see, energy, yes, it is directly proportional to z square. Okay, it is inversely proportional to n square. So that is still there, no problem. Also, energy is directly proportional to mass. And I told you the importance of mass. It should not actually be mass. What should be there instead of mass?
Reduce mass.
So originally the formula should have mu m raised to 4. And by the way, technically there should be a minus sign too. So if you want, you can write minus sign. That's also fine. This being technical. Yes, Rishita, this is the first slide. And this minute. So I can say that energy would be minus of x. The technical formula is mu into e raised to 4 upon 8 n square h square epsilon naught square and then z square. Mu is basically reduced mass. Okay. So obviously only in case of an electron and the nucleus, where you have proton, you can say that it approximately becomes equal to electron people. Because when you write me into mp, the proton or nucleus, just like nucleus also. Suppose n is nucleus, m is mass of nucleus, which is very large. Mass of nucleus, which is very large comparatively to mass of electron. Because electronic mass is of the order 10 raised to minus 31. 9.1 into 10 raised to minus 31 kg. But protonic mass and neutronic mass, all of them are 1.67 into 10 raised to minus 27 kg. They're 10,000 times greater, people. 10 raised to 4 times greater. So obviously nucleus mass is very much heavy than the electron mass. Okay. So when you write mu, which is me mn upon me plus mn. Okay. So this is actually, you throw mn in the denominator, we get me upon mn plus me upon mn, and then this becomes me upon mn. Sorry, mn upon mn. I just thrown mn in the denominator now. So me upon mn becomes and mn upon mn becomes. Me upon mn is negligible. 1 upon 10,000. It's 10,000 times greater. Actually, if you take the proper ratio, then we get 1836 because it's 9.1 and 1.67. But 1 upon 1,836, that is still very negligible. Call it 0 people approximately. Okay. And mn upon mn is cancelled, you get 1, and hence mu becomes equal to me. So and hence in hydrogen atom, when you talk about this mass, this is in case of hydrogen atom, this is mass of electron. But a general formula is this, where you should have a reduced mass. And we have taken an example of positronium to understand that reduced mass becomes now in case of positronium, reduced mass is not me people. You remember what is the reduced mass in that case?
Me by 2.
by 2.
Yes, by 2. Okay. Make a note, please. Ask me if you have any questions. This is just a small revision because we will require these things. So,
Yes, sir.
shall we next? Let me click right. Okay. Now, if we talk about potential, people, potential of any two charges, potential between any two charges, it is 1 upon 4 pi epsilon naught q1 q2 upon r. That's it. Yeah? But if you talk about a hydrogen atom or a hydrogen-like atom, what you have in between is basically a nucleus. Now nucleus has z protons, people. Okay, and it has a minus z neutrons. A minus z neutrons. Okay, but neutrons don't have any charge. So what is charge of a nucleus? Charge of a nucleus? Yes, it is just z into charge of proton, people. But you can write a minus z into charge of neutron. You can write a minus z into charge of proton, but neutron does not have any charge. Z is the number of protons, a minus z is the number of neutrons, people. Always in any atom, when you write ax z, there is always number of protons, a minus z is always number of neutrons, people. Okay, so total charge will be number of protons into charge of proton, number of neutrons into charge of neutron. But neutron does not have any charge. So you just have z into charge of proton, that's nothing but plus e, people. So charge of nucleus is z. Okay, now electron is revolving around it. In hydrogen atom or hydrogen-like atom, whatever, electron is revolving around it. So just one electron, H-like atoms. I hope you remember what is the meaning of H-like atoms. Even if you have 2 electrons, you have to donate 1 electron so that only 1 electron will get. Even if you have 5 electrons, you have to donate all the 4 electrons so that only 1 electron will get. In H-like atoms, only 1 electron will remain, people, no matter what. However, nucleus does not change. Nucleus remains intact, people, for individual atoms. Okay. Anyway, so for hydrogen-like atoms, you always have 1 electron, people, just 1 electron. So the charge of electron, that is minus e, actually, to be more precise. Okay. So what is the potential between them? So I can say this is 1 upon 4 pi epsilon naught into q1, that's charge of nucleus, q2, that's charge of electron, upon r. R is radius. R is radius. So this is 1 upon 4 pi epsilon naught. Qn, that's ze, qe, that's minus e upon r. So we have got minus of 1 upon 4 pi epsilon naught ze square, or you can just write e square upon r into z. This is potential V of r. V is a function of r and r. R is energy. No, potential energy will have r square actually. So no, so potential energy is sorry. Yes, this is potential energy. Write it you. Don't write me.
Yes, potential energy is stored between nucleus and electron.
Yes, potential energy is stored between nucleus and electrons. Potential is 1 upon 4 pi epsilon q by r. Yes. So this is potential energy. Actually, in many books they write potential energy also as V people. Okay, in many books, potential energy is also written as V. Forget books. Schrodinger equation. That V is only potential energy there. In Schrodinger equation, you write V of x people. That is potential energy because it's energy equation if you remember.
Yes, sir.
So even though I've written U here, you can later replace it with V, but just remember it's potential energy. So this is potential energy of a hydrogen atom people or hydrogen like atom. Done, people?
Yes, sir.
Let me finish writing. Next. So what is our Schrodinger equation? Schrodinger equation is d square psi upon dx square plus 2m upon h square into E minus V into psi. Okay, this is 0, where V is actually potential energy. In hydrogen atom, you are denoting it by U, but it's the same thing. Okay, so we have a d square psi upon dx square plus 2m upon h square into E minus of what is V now? V is minus 1 upon 4 pi epsilon naught E square upon R into Z. Achha, by the way, there is a small mistake, a small huge mistake. I cannot write d square upon dx square. I have to write del. I have to write del square. It's a 3D. It's a 3D system now because you are anyway having radius and it's a sphere. It's a spherical system. So actually, we should be using spherical coordinates. So instead of writing d square psi upon dx square, you will have to use del square psi. Okay, del square psi plus 2m upon x square people. Okay, into E minus V psi. This is 0. Why del people? Remember, when you talk about an atom, it's a spherical system, spherical polar coordinate system. Okay, so it's a 3D system this time. 3D system. So you cannot have d by dx actually. Okay, so del square psi is del square psi plus 2m upon x square E minus V psi. This is 0. V is potential energy. That's fine. Okay, so we have got del square psi plus 2m upon h square into E minus V, which is given by minus 1 upon 4 pi epsilon naught. So minus minus plus 1 upon 4 pi epsilon naught into E square upon R square into we have got Z into psi. This is 0. Okay, value of Z is 1 for hydrogen. Z is 1 for hydrogen atom. So that's fine.
Sir, E square upon R only.
Yes. Otherwise it becomes force. E square upon R. Remember, psi here is a function of r, theta, and phi because you have spherical polar coordinates. Okay, it's a function of r, theta, phi, spherical polar coordinates. And then this has a very humongous long large derivation which you do, which we have not to do. And I'm not sure if you have learned this too in BSc or not. Even in BSc colleges also, they usually skip the derivation of spherical polar. But anyway, before I proceed, a very important note because that's a common mistake which students tend to do. That is, people when you talk about limits for whatever kind of equation that will be given to you in hydrogen atom. For example, they will give you wave function. They can ask you probability. So you all are habitual with the formula probability as, let's say, P of x, which goes from, for example, minus infinity to infinity. If you are using minus infinity to infinity for all space, like, okay, for example, what is normalization? Normalization.
All space.
So we write all space now, and we write minus infinity to infinity basically. If at all space is not given to us or we don't understand, and then we write psi star psi dx. This is
Equal to 1.
equal to 1. Okay. Now the thing is, things that will change for hydrogen atom.
Sir, dx dy by dz.
Basically, it becomes volume. And I told you this too at the very beginning also. If you have a 3D, then instead of dx, you write d tau. It becomes volume. That's the first thing. Next, second thing, actually, you should not be writing minus infinity to infinity here. So let's write psi star psi d tau. That's also fine. This is 1, all space. Now, what is a volume element people for a sphere? We have done this in center of mass.
RD. R square
RDR.
dr.
Sin square theta d theta d phi.
Okay.
See, the thing is, d tau, you may have by heart it's actually r square sin theta dr d theta d phi. It's not just r dr d theta.
Yes, sir.
Okay, r square sin theta dr d theta d phi. But you don't need to use this. You can directly use 4 pi r square dr. Because if you integrate d theta d phi, eventually you get 4 pi. Okay, if you integrate sin theta d theta d phi for a sphere,
Yes, sir.
for a complete sphere, you can always use volume element is surface area into thickness. If you take a whole sphere, if you want to take an element of it, just element of the sphere, it means you are taking surface area of the sphere into thickness. That's the volume of the element. What is the volume of the element? Volume of this element is nothing but surface area, like 1 surface area, 2 surface area, 3 surface area, 4 surface area, thickness into surface area. That's it. Okay, so surface area 4 pi r square into dr. So that's one thing. Next, one. Another common mistake a student would do is to write limits as minus infinity. That's still wrong. People, it's radius, it's not position. Radius always goes from 0 to infinity. It's not minus infinity. It's radius. It's not position. So this will go from 0 to infinity of psi star psi 4 pi r square dr. This is 1. So this is a normalization condition. And main two important things that I wanted you to understand here, that you don't have dx anymore. Instead of dx, you have d tau, and you can write any volume element as basically nothing but surface area into thickness. So that's 4 pi r square into dr. And another important thing is for position, if you had x, y, z, they go from minus infinity to infinity. But radius people, it goes from 0 to infinity. Okay, but make a note of this. Ask me if you have any questions. Do not hesitate. So in 3D, you write this, okay? In cycle, you have to take care. So R goes from 0 to infinity. That's very important to recall. Ask me if you have any questions. Don't hesitate. Then people shall we?
Yes, sir.
And also, so if you plot this potential energy graph, U is inversely proportional to negative of 1 by R. Potential energy U of R, that's minus 1 by R. So just in case if you want to plot a graph of this, remember it will be in fourth quadrant. Here you have R and here you have potential energy. So yes, it is exponentially decaying, but you cannot write in the first quadrant because when R is positive, potential energy is negative. So it goes like this. And R is always positive, it's radius. So this is the graph, okay? U of R is inversely proportional to negative of 1 by R. It's not in first quadrant, it will be in fourth because R is always positive, so potential energy will always be negative. R is radius, not position. Okay? Next. Now let's recall this R theta phi people, okay, of spherical coordinate system. So we have done this in that 2D, 3D acceleration velocity wala chapter. So what we can do is, let's say we have got x, y, z plane. Okay, and you can take a sphere, but sphere is just for your reference, people. Okay, now take any point, not necessarily on the surface, any point inside the sphere. You have a point P, I have taken inside, not necessarily on the surface. Okay, let's say this is origin. Okay, sorry, now. So this P has got coordinates like x, y, z, and this P has got coordinates r, theta, phi. I just want to make you recall what was r, what was theta, what was phi. So r is nothing but radius, basically distance of point P from center, people. So that's r. Done. Okay. What was theta? Theta was a colatitude, angle with respect to z axis. That's theta, people. Okay. Theta was called as colatitude. Okay. And when you talk about phi, people, so phi was first we have to drop the projection of P on xy plane. Okay. So you can draw an xy plane for your reference. Okay. This is just an xy plane that I have drawn. X axis, y axis. So I've just drawn a projection of this point P on the xy plane. Let's say P dash. Okay. Now this P dash subtends an angle with the center, people. Subtends an angle with the center. This angle is known as phi azimuth. This is our phi. Phi is nothing but the angle of the projection of point P on the xy plane. Okay. Take a look. And for a sphere which is our atom usually. So for a sphere, what are the limits of theta and what are the limits of phi, people usually? Let's understand that. Now understand, I need you to imagine this. How do we draw a sphere basically? So suppose you have a point P. Okay, take that point P on z axis. I need you to imagine this with me now. Take that point P on z axis, people. Okay, so let's say this tip of the pen is the center. Okay, this is the center, and this is point P. And now tell me one, if you rotate point P, the angle that it makes with the z axis, that is theta, correct? We just learned that the angle that you make with z axis, that's theta. So all you have to do is you have to rotate this pen by how much? By 180 degrees. That's it, by 180. So what you will get, people? A disc structure. It's like suppose you have a pencil or a chalk. If you have a chalk, if you just rotate the whole chalk by 180, what you will get? You get a disc. Can you imagine a semicircular disc?
Semicircle.
A semicircular disc. You have a chalk, people. This is a chalk on the board. Just keep this chalk on the board and just rotate it by 180 degrees. It will create a whole disc now. So theta you have rotated by how much? 180. Now tell me one thing. If you rotate this whole disc that you have, okay, this whole disc. Suppose you're holding this disc. Whatever it is, this arc that you have. Suppose you're holding this arc. Rotate it by 360 degrees now. Rotate this whole disc that you have like this. Okay, by now 360 degrees. You need to imagine this whole rotation of the disc. Hold it like this, the whole arc, and rotate it. Don't you think it will create a sphere?
One guess, yes.
So what did you do? You rotated it horizontally now, and horizontal angle is which angle, people?
Phi.
Azimuthal. Phi. So if you rotate it by 360 degrees by 2 pi, you get a sphere. So that's how you form a sphere. Theta goes from 0 to pi, just 180 degrees. You rotated the chalk, people, by only 180 degrees. But the disc that you have now got, you rotate the whole disc by 360 degrees, people, and you will get a whole sphere, 0 to pi. So theta goes from 0 to pi, and phi goes from 0 to 2 pi. R was going from 0 to r. So how did we decide R? Basically, you took a point P, okay? You took that point from the center and you extended this. Now this becomes a point P. This is the R. Now just rotate R by 180, you get the disc. Rotate the whole disc by 360 degrees, you get the whole sphere. So these are the limits of a sphere all the time. Ask me if you have any questions. And hence I said that, when you integrate, for an example, d tau, when you integrate d tau, okay? So integration of d tau is nothing but triple integration of r square sine theta dr d theta d phi. Okay, so for a sphere, what happens is, you can write this as, okay, r goes from 0 to r, or just split them now. So you have r square dr, okay, then you have sine theta d theta, okay, and then you have a d phi. You just split the respective terms with each other. R is going from 0 to r for a sphere, correct? Theta is going from 0 to pi for a sphere, correct? And phi is going from 0 to 2 pi for a sphere. Now. And as you see, you have got r square dr, which goes from 0 to r. Keep it as it is. Just calculate these two. Just calculate this two. Integration of sine theta becomes cos. Calculate integration of
Minus
this will become eventually integration of sine is minus cos. Calculate these two, you get 4 pi now. And hence I said that instead of writing r square sine theta dr, you can always simply write 4 pi r square dr directly. For a sphere, this will always work. Okay. So d tau, instead of writing r square sine theta dr d phi, you can write 4 pi r square dr. And you can check this integration of sine, that's basically minus cos, which goes from 0 to pi. Integration of d phi, that's pi, 0 to 2 pi. Okay, so we don't like minus sign, so what we can do is we can use minus sign to shuffle the limits. I can use this minus sign to 0 to pi will become pi to 0 people, and then 5 goes from 0 to 2 pi. So you have got cos 0 minus cos pi. Okay, cos 0 minus cos pi. You have got 2 pi minus 0 people. Cos 0 is 1, cos pi is minus 1, minus is plus. 1 plus 1 into 2 pi, you are getting 4 pi people as expected. You will get 4 pi. See, integration of sine is minus cos, integration of d pi is pi. I've used minus sign to shuffle the limits. So 0 to pi becomes pi to 0. And just upper minus over. Cos 0 minus cos pi. Cos 0 is 1. Minus of cos pi, which is minus 1, so minus 1 becomes plus 1 plus 1. 2 pi minus 0. So 2 into 2 pi, that's 4 pi. Clear, everyone?
Yes, sir.
Yes, sir.
Chalo, next. Proceeding ahead, okay? Tell me if you're writing this. So just like in 2D box, 3D box, I had told you that wave functions you can actually explicitly split them. Like you used to write psi of x, y, z. They're allowed, to have been split like psi x, psi y, psi z. Any day. We learned this when you used to write root of 2 pi L sin nx pi x by L, root of 2 pi L sin ny pi by L, root of 2 pi L sin nz by z by L. Okay. So very similarly, here also psi of r theta pi, even this can be splitted people in its respective coordinates. So you can write psi r of r plus psi theta of theta, so not plus into psi theta of theta, and then psi phi of phi. The thing is, book does not use this notation. So you may have seen that instead of writing psi r, they're writing capital R. It's fine. Instead of writing psi theta, they're writing capital theta people. That's also fine. And instead of writing psi phi, they're writing capital phi. That's also fine. They are only notations. You can write fr, g theta, k phi, whatever. So r is nothing but wave function associated with r. Theta theta is nothing but wave function associated with theta, and phi of phi is nothing but wave function associated with phi people. Make a note. Obviously, because we have capital and small, so these are capitals and small people.
सर आप कौन सा यूज करेंगे?
नहीं, हम ज्यादा यूज नहीं करने वाले, but still we have to use this. Then after the whole long of derivation, people, okay, all these individual, like the point is, all you have to do is you have to substitute this IR theta phi here, people, this is the equation, and then a lot of derivation manipulation is done, and eventually all these wave functions are found out. People. This, and this is found out. So we'll directly write the results of it. Okay, sure. You can say this is equation 1 if you want. So let's write the results directly. You can write, we put them in the Schrodinger equation, and the solution is found out to be right now. We put them in the Schrodinger equation, and solutions are found out to be. And solutions are found out to be. Let's write. Let's start with 5b. So this wave function associated with the azimuthal, people. Wave function associated, which is a function of only azimuthal. It's not a function of theta. It's not a function of r. It's a function of only phi. Only phi. It is found out to be e raised to I ml of phi, people. I is a complex number. What is ml? ml is, people, orbital magnetic quantum number. Orbital magnetic quantum number. How do we calculate this? I will teach you in some time. Orbital magnetic quantum number. Well, if you can write if you want. So ml, people, takes all the value. It takes all the value from minus L to L. It takes all the value from minus L to L. Okay. And what is L, people? L is orbital angular momentum quantum number. Orbital angular momentum quantum number.
So this is called other name as azimuthal quantum number.
If you want, you can also call it that. Okay. And what is orbital angular momentum quantum? Like what are the values it takes? It takes, people, all the values from. It takes all the values from 0, 1, 2, 3 until n minus 1. And what is n, people? N is the principal quantum number of hydrogen atom, which we already know. Principal quantum number, which we already know. The hydrogen atom, which starts from 1, people. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So as you can see, phi is only a function of phi. It's not a function of r. It's not a function of theta. Okay, people.
Yes, sir.
Let me write it. Next, let's talk about theta of theta. Again, it should be a function of only theta. It cannot be a function of r. It cannot be a function of phi. And this is found out to be sine raised to mod of ml, people. Mod of ml of theta, like sine square theta, sine cube theta, something like that. Sine raised to mod of ml of theta. Okay, into some function of cos theta. That varies, people. You don't have to worry about it. Some function of cos theta. As it's a function of only theta, that's important. ml we already know. Okay, ml we already know. And r, which is a function of, again, r. It cannot be a function of theta. It cannot be a function of phi. Okay, it is given by e raised to minus cr upon n. C is a random constant again. Don't worry about it. N is principal quantum number that you already know. R raised to L. L is angular momentum quantum number that you already know. Into some function of r. We don't have to worry about it. Again, it's a function of only r. It's not a function of theta. It's not a function of phi. Where we are going with this, you will soon understand. Don't worry. I have it all planned. C is a random constant. Huh? C is just a random constant. Okay. Sure. So summarizing all of them in one page once again. So what do we have, people? We have got phi, which is a function of phi. It is just e raised to I ml of phi. Then we have got theta, which is a function of theta. It is just sine raised to ml of theta. Sine raised to ml of theta into some function of theta. Then r, which is a function of only r. It is given by e raised to minus cr upon n into r raised to L into some function of r. Now, importantly to see is, as we see, this is only a function of phi, this is only a function of theta, this is only a function of r. However, people, phi, the azimuthal, or you can say the wave function corresponding to only azimuthal value, people, it depends only on angular momentum quantum number. It depends only on angular momentum. Sorry, ML is magnetic spin quantum number. Magnetic quantum number, people. Sorry, orbital magnetic quantum number. Okay, so phi depends only on ML, orbital magnetic quantum number. Next, theta depends on only ML. Again, theta also only depends on ML. Even this depends on pardon?
F of cos theta, sir. In second.
Yes, f of cos theta, absolutely. Yes. So even this depends only on orbital magnetic quantum number. But R, however, depends on principal quantum number and angular momentum quantum number. N and L on two things. But people, when you talk about the whole wave function psi, which is a function of r, theta, phi, which is a function of, if you remember, r of r, theta of theta, and phi of phi. Okay. So if you substitute them all, people, if you substitute them all, it means wave function will depend on all the quantum numbers n, l, m. Okay, and it will be a function of theta. It's a function of phi. It's a function of theta. It's a function of r, people. So the value of psi, people, it depends on principal quantum number. It depends on angular momentum quantum number. Depends on magnetic orbital quantum number. It depends on n, l, m, all of them. Make a note. So the point is, just like 1D box, we used to just write, psi n. In 2D box, you used to write psi nx, psi ny. In 3D box, you used to write sin nx, ny, and nz. This was in 1D box. This was in 2D box. This was in 3D box. Okay, and I think same notations were for harmonic oscillators too. But however, for hydrogen atom, people, we will write psi n, l, ml, people. Even this will have three terms. Even this will have three terms. This is for hydrogen atoms. Clear? N, L, M, L. In this order only. Always in N, L, M order. Always. N, L, M, L. Are you with me here, people?
Yes, sir.
Yes, sir.
And remember how to calculate L, how to calculate M. We'll be taking more examples, but you have noted that here already. Now, ML takes all the values from minus L to L, and L takes all the values from 0 to n minus 1. This is very important. Okay? ML takes minus L to L, and L takes 0 to n minus 1. Next. Now let's talk about degeneration. Okay? And soon at the end of degeneracy, you are going to have a very wow feeling at the end of degeneracy. Okay, let's see what. So first of all, what is energy of a hydrogen atom? We learned a wave function, like we just learned that for hydrogen atom, wave function is, it depends on all, it depends on L and wave function when you write R theta phi, it depends on all of them, N, L, and ML. But when you talk about energy, you already have the formula, which was pi me raised to 4, okay, pi me raised to 4 upon n square h square epsilon naught square. Wait, I always write it off. What is the exact formula?
m e power 4 into z square upon.
There's no pi in the numerator.
Yes, sir. Pi nahi hai usse.
Pi
Pi
तो
nahi
नहीं
m raised to 4 upon, I think no, my pi probably like exists if you write it in terms of h square, right? Okay. So energy is basically, just dictate that please, me raised to 4 upon 8
8 n square h square epsilon naught square.
and then there is z square if you want to use it. Right now we're talking about just hydrogen. Let's keep it for hydrogen. Okay. Okay. So as we see, energy, however, it's a function of only n. Energy depends only on n. It does not depend on L. It does not depend on ML. What is the meaning of it, people? Degeneracy will definitely exist. It means as far as n is same, doesn't matter if L changes or ML changes. As far as n is same, people, degeneracy will exist. It's like something. Can I say, for example, the value, the energy of psi 100, it will be same as the energy of psi 111. It has to be, no? Because
Yes,
if n is same, people, if n is
Yes,
same, you can say that energy will be same. However, by the way, this is absurd. This doesn't exist. I'm just giving you a rough idea here. 111 doesn't exist. It doesn't even exist. But the point is, if you write, for example, let's say psi 321, then the value of psi 311. They both will share same energy for sure. As far as the n value is same now, people, L and L, if that change, we don't care. Energy will be same. It means degeneracy can exist. Okay? And now we have to learn degeneracy of each state. So, copy this first. And you can make it hence, as far as n is the same in wave functions, comma, energy will remain same. Energy will remain same. Therefore, degeneracy can exist. Therefore, degeneracy can exist. And I told you at the end of the degeneracy of this, we are going to have a very happy realization. So let's understand what and how.
This energy is the energy of nth level, like
Yes, absolutely. K shell, L shell, N shell. Okay. N equals to 1 is K shell, N equals to 2 is L shell. That seems orbit theory. Okay. Remember, N starts from 1, 2, 3, 4. Okay. So this is basically first level. Okay. Second level. Third level. Okay. The first one is basically ground state. Second level is basically first excited state. Third level is basically second excited state. Ground state is basically K shell. First excited is L shell. Second excited is M shell. Note this if you want. Done? Let me try again.
Done, sir.
Okay. Others, let me finish that. Okay. Let's learn degeneracy now. Okay. Degeneracy. Okay. So let's start with the first one. When principal quantum number is 1 people. What are the values that L can take? L can take all the values from 0 to n minus 1 people we have it. It means 0 to 1 minus 1. It means 0 to 0. How many values exist between 0 and 0? Just 0. So only one value. L can take only 0 as a value, cannot take any other value. And hence I told you that psi 111 doesn't exist because if n is 1, L cannot be 1. L has to be 0. There is no other option. Okay. So L can take only 0 value. Okay. L can take only 0. Next. What about ML people? ML takes all the values from minus L to L. Okay. So this takes minus 0 to 0. How many values exist between them? Nahi na, L
0.
It is only 0. Na, 5 minus 1. L is only 0. Na. It's not minus N to N. It's minus L to L. L is only 0. Okay. So it takes minus 0 to 0. It takes only one value. Equals 0. That's it. ML also cannot take any other value. ML can take only 0. It means what are the possible wave functions I can have? There is no option. N is always 1. L is always 0. ML is always 0. So when I write N, L, ML people, okay, there is only one option here, psi 100. Only one option. There is no multiple option here. It means ground state is non-degenerate. Only one state. Only one state. It means I can say ground state is non-degenerate. Ground state is non-degenerate. Or you can say one-fold degenerate, whatever. Or you can say one-fold degenerate. Because all of them, this state will have only one energy. No? Energy here will be what people? Energy here, like we know En, the formula is n square h square. No. So
My m is 4 z square upon.
Forget it. 8 n square h square epsilon naught square. So here energy would be E1, which is m raised to 4 upon 8 h square epsilon naught square. Okay. So this is the energy which is shared by only and only just one state, people. This energy is shared by only one state. I hope you understood this. Tell me if not. Then people.
Yes,
Yes,
sir.
Yes, sir.
Now let's learn second one. When n is 2. Now we'll have fun. Okay. Okay. So first let's talk about energy, which is E2. So that's pi me raised just me raised to 4 upon 8 n square. That's 2 square h square epsilon square. So this is me raised to 4 upon 2 square is 4, 8 4s are 32 h square epsilon square. Now who always share this energy? That's the question. How many degenerate states this has? Okay. Let's understand. So let's talk about L people. L can take values from 0 to n minus 1. Okay. So 0 to n is 2 this time. 2 minus 1. It means 0 to 1. So it can take two values this time, people. L can take 0 to 1. How many values? We have two values. Huh? L can take 0 and L can take 1 people. There are two possibilities in case of L. Okay. Now let's talk about ML. ML can take. ML can take.
5 well.
Just a second.
Three well, three.
Hey, chill maro. Hero. ML can take values from minus L to L. That's okay. That's fine. This is good. But this is where you guys are going wrong. It's not 3 values. The reason is that when you say ML can take values from minus L to L, L has 2 possibilities. ML also has 2 possibilities now. When L is 0 and then when L is 1 people. David. So actually lost the earbuds of this. It fell somewhere. But without earbuds, it's irritating now.
मेरे पास एक एक्स्ट्रा है
Let me see if this fits. Let me try the radio. Okay, better. So when L is 0 people, ML will take all the values from minus L to L. Okay, so minus 0 to 0, only 0. But yes, when L is 1, ML can take all the values from minus L to L. It means minus 1 to 1. It means minus 1, 0, and 1 people. So how many combinations of energy I can have now? Listen. When you talk about psi NLM, okay, so N is always 2, N is always 2. But when L is 0, N is 0, okay, psi is always 2. But when L is 1, ML has 3 possibilities. ML can be minus 1. When L is 1, ML can be 0. When L is 1, ML can be 1. Degeneracy 3 nahi hai people. Degeneracy how much? 4. Copy please. Degeneracy is 4. When N is 0 and L is 0, sorry, when N is 2 and L is 0, ML is always. Give me 2 minutes. I need to pick another year, but otherwise it will not fit. Copy this. Do you want to know a joke here right now? I cannot hear you because I'm not put the earphone. The thing is, earbuds were not in the ground, they were in my ears. Earphone had fallen, but the earbuds were only in my ears.
It happens, sir.
And I was looking at here and there. If you're saying something, I'm still not able to hear this. Now I can. Okay. So people, please ask me if you have any doubts in this now. Okay. So when N is 2 and L is 0, ML is only 0. But when N is 2 and L is 1, ML can be minus 1, ML can be 0, and ML can be 1 people. So we have got 4 possible states. Done? Shall we?
Yes, sir.
Write down. Degeneracy is 4 or 4-fold degenerate. Next. Let's talk about third. 3. When N is 3 people. Okay. So energy would be m raised to 4 upon 8, 3 square, h square, epsilon square, whatever. Now let's start with L. So L is, now who will share this energy? That's what we want to discuss now. L goes from 0 to L, n minus 1. So 0 to 3 minus 1. So 0 to 2. So L can take 0, it can take 1, and it can take 2. It can take all the values. Now you have to find respective ML people. ML can take minus L to L. Okay. But now there are 3 cases. 1 when L is 0, 1 when L is 1, and 1 when L is 2 people. So minus L to L, minus 0 to 0, that's 0. Minus L to L, that's minus 1 to 1. So that's minus 1, 0, 1. And minus L to L, that's minus 2 to 2. So that's minus 2, minus 1, 0, 1, and 2. You can take all the values from minus 2 to 2 now. So these values. So what is the degeneracy? As we understand. 3, 0, 0, 1 possibility. 3, 1 minus 1, 3, 1, 0, 3, 1, 1. 3 more possibilities. 3, 2 minus 2, 3, 2 minus 1, 3, 2, 0, 3, 2, 1, and 3, 2, 2. 5 more possibilities. We have got 5, 6, 7, 8, 9. 9 possibilities this time, people. Degeneracy is 9. Degeneracy is 9. What are the possible values? Psi 3, 0, 0. Okay. And psi 3, 1 minus 1. We can write it here. Psi after psi 3, 0, 0, I have psi 3, 1 minus 1. Then psi 3, 1, 0. And psi 3, 1, 1 people. And then you have got psi 3, 2 minus 2, psi 3, 2 minus 1, psi 3, 2, 0, psi 3, 2, 1, and psi 3, 2, 2 people. These are the possible states. All of them will share same energy because for all of them N is same people. For all of them N is same and energy depends only on it. Since energy depends only on it, all of them can share same number of energy. So we have got 9-fold degeneracy. Are you with me, people?
Yes, sir.
Okay. So a very good 1-mark question could be which of the following is an absurd wave function. They can give you 4 options. 3 of them would be logical and 4 would be illogical. Like something like this they can give, For example, psi 3, 3, or let's say psi 3, 3, 1. This is important.
सर जो आपने साई 3 2 minus 2 ये कैसे लिखा सर?
नहीं मतलब 3, 2, minus 2.
तो L2 कहाँ है?
L2 है ना?
ओके ओके सर.
है ना?
हाँ
so
सर.
So when L is 2, ML can be minus 2, ML can be minus 1, ML can be 2, ML can be 1, ML can be 2. Ask me if you have any questions. Don't hesitate, please. Yeah. I hope you have copied this. Shall I go to the next page?
Sir 1 minute only.
Okay.
Okay sir.
So basically, we have found out that the ground state, okay, when you write n equals to 1, which is first level, okay, which is ground state, okay, or you can say it is K shell, okay. What is the degeneracy, people? Right now we have found 1, it's non-degenerate. For n equals to 2, we have found out which is second level, okay, first excited state, L shell, degeneracy is 4. N equals to 3, we have found out third level, second excited state, M shell, degeneracy we have found out is 9. Something in the chat box. So yes, Mona, that's correct. No, absolutely. So that's what I was about to ask. So for people, nth state, if you talk about for nth state, and if you talk about, yes, absolutely. So we have got, sorry, nth level. What is excited state?
N minus 1.
N minus 1 excited state. Okay, second level, first excited, third level, second excited, nth level, n minus 1 excited state. Whatever shell, we don't care. Okay, we don't know obviously. So whatever shell, and then we have got n square, now because 1, 4, 9, which is 1 square, 2 square, 3 square, and then we have got n square. So please, I had the degeneracy formula for hydrogen atom, that's n square. And don't worry, this is not a happy realization yet. I'm yet to give you the happy realization. Okay?
Yes, sir.
Chalo, let's talk. Now, actually, we have learned only 3 quantum numbers, NLM, because that is how they are famous. Like usually they write quantum numbers as NLM. But there is a 4th quantum number which comes into picture, especially for fermions people. A 4th quantum number which comes into picture, especially for fermions. And that is known as MS, which is
Yes.
magnetic spin quantum number. Magnetic spin quantum number. And it can take only 2 values all the time. It is not dependent on n, it is not dependent on l, it is not dependent on m. It has 2 values, people, plus or minus half. Plus half and minus half. That's it. Basically, I'm a spin people. I'm a spin, upspin, downspin. Plus half, minus half. Plus half is upspin, minus half is downspin people. Plus half is upspin, minus half is downspin. Okay, so if I would ask you that in a hydrogen atom, if in the ground state I have got fermions, okay, then what is the degeneracy? Then answer is not 1 people. Then answer is not 1. Then ground state becomes degenerate state. Why? Because now people, wave function, when you write psi NLM, there is actually, like we wrote NLM, ML you have, now you have a 4th quantum number MS people. So every NLM will have a plus half and a minus half. Every NLM will have a plus half and a minus half. So for example, okay, when you talk about ground state, okay, what did you have? Psi 100, but now it will have 2 possibilities. One is people psi 100 plus half, okay, and it will also have psi 100 minus half. So how many electrons it can have? How many fermions it can have in the ground state people? 2 electrons. 2 electrons in K shell. Okay, even L shell you have learned since childhood now. L shell has how many electrons? Always maximum
8.
8.
Now you will know why it is 8. Now. Why it is 8 people? Because when you talk about
Degeneracy
L
is 4.
shell, but degeneracy is 4, and now you have spins too.
So
Spin double हो जाएगा ना?
That's it, people. So when you talk about L shell, okay, when you talk about L shell, it means it's your first excited state. Okay, it's your second level. So when you talk about second level, okay, we have got psi 200, we have got psi 210 minus 1, we have got psi 210, and we have got psi 211. This is what you have already learned. But now if you will include MS also, then all of them will have 2 possibilities. This will have psi 200 upspin, which is plus half, psi 200 downspin, which is minus half. This will have psi 21 minus 1 upspin, which is plus half, and this will also have psi 21 minus 1 downspin, which is minus half. This will also have 2. This will also have 2. Total, we have got 8 electrons people, which can share same excited state, which can share same energy. This is the reason that L shell can accommodate at a maximum of 8 electrons people. It can accommodate at a maximum of 8 electrons. Start copying from here. And what did you learn for M shell KLM? What was after 2 8? What is
18.
18 now? See if you're getting 18 or
9
not.
to the
9 to
18.
the 18 people. Okay.
So this way 2 n square. That's in our
Yes. So basically it's 2 into n square. That is when you include spin. So for fermions it's 2 n square. Otherwise for bosons you can say it's only n square. Or for spinless fermions also it's only n square. Boson does not have. Boson can be not boson. Spinless fermions it's n square, and for fermions it's 2 n square.
सर बोसॉन तो उसमें शामिल ही नहीं है ना?
नहीं उसमें है नहीं, included नहीं है. Forget it. Okay. So we have got degeneracy. If you include spin, it is 2 n square. I'll copy this. Shall I go to the next page? Copy this. And similarly, you can write for M shell, we have got 18 electrons people. Remember, quantum mechanics was developed the way after the orbit theory of Bohr. Like this NLM, the quantum numbers and everything. So when everything fits in, like the way this defines the orbit theory of KLM and everything. Again, this makes us believe in the theory that we have developed that it is definitely going in the correct direction. The idea of degeneracy, we have connected it to all the way back of our 8th and 9th standard theory when we learned for the first time that K shell has 2 electrons, L has got only 8, and M has got 18. Why only 2? Why 8 and why 18? We understand that with this.
Excuse me, sir.
Bola.
Sir, in junior classes, we were taught that we have 8, 18, but here we are getting to 8, 18.
No. That is for orbit filling. That is for stability. That what you are talking about is 2, 8, 8, 18, 18, and that 32. This is for stability.
Yes, sir.
But
Yeah,
maximum,
yes, sir.
but maximum that the KL and M shell can occupy is only 80. Maximum M shell can occupy only 80. This can go beyond 80.
Okay, sir.
हाँ.
Okay, sir.
Yes, no problem. Chalo, done people.
So just out of curiosity, why are these shells named as like that? A, L, M, and why not anything else?
Did I ask you this question at the very beginning?
Yeah,
Never give you the
but
answer.
no, you didn't give us an answer.
Okay, okay, I'll give you the answer that today. Okay. So this is the question people, actually I had asked it to my professor in 9th standard. I was very worried whether I should ask this question or not, but I was like, obviously it's a silly question, but the question is a question. I told him that so I have a question why KLMN is it starts with KLMN and why not with ABCD? Then everybody obviously started laughing, and people from the backbenches they started commenting. And then they are like, "Arey, scientist ka naam kaise hoga?" But I'm like, "It's Neil Bohr. He could have started with N. So why K then?" And sir told genuinely that see, I don't know the answer of this, and I have never read a book which answers something this fundamental, and I don't even think that there could be a reason to this. Like he could have done. It could have started with K just like as it is, and he literally went on to comparing that with Karan Johar. He's like, see, Karan Johar also has all his movies starting with K all the time. कुछ hota hai, kabhi kabhi top. And I'm like, okay, so basically, sir does not know the answer. That's fine, but then why do you have to wind up and relate it with superstitious or whatever? I'm like, okay, sir, no problem. But he said, but however, there could be an answer. I don't know, but you are allowed to research and let us know maybe in the next class if you come to know about this. Yeah, so that is very ego pe aa gaya. Sir is like, go and find yourself if you are just curious to know about it. I was like, okay, this is the story of 2007 or 8. Okay, so back then having mobile phones and having laptops was not popular at all. So what I did was I went to a cyber cafe. Okay, so in the cyber cafe, obviously I first said, okay, and I first typed the whole question. Google is also like, Google is telling no results found. Okay, then I had to trim my question, like I had to ask it appropriately. But then there were answers, but that went way beyond my understanding. Like for example, using all of this quantum theory and everything, this and that, whatever, I don't know, which went beyond. But then I found answers on a page, Yahoo Answers. I'm not sure if these are today's students are aware of Yahoo. You know Google.
Yes,
Yahoo
yes.
is also platform. So Yahoo Answers had an answer back then, which I could understand. Okay. So I was like, I found the answer and I penned it down. I went to the class next day and I told my teacher that sir, I got the answer. So he's like, answer what? He's like, I told him that sir, why it starts from KLM and why not from ABCD? He's like, it has an answer. I'm like, yes sir. Okay, come to the booth. and he gave me the chalk, and he went down and he sat on my bench. He like explained. People, honestly, I don't remember any other incident before this. Like very hazy memory if I had held a chalk before that. So that was the first day, like you can say, the beginning of my career as a teacher. I would like to pinpoint that moment because that was the first time I remember holding the chalk and being confident because I knew I had an answer. I knew I'm going to explain it, and I knew at the very end people are going to clap. So I was like, okay, sir, and I confidently explained it. I will tell you the answer. Hang on. So at the end of it, what happened was after the explanation, there was pin drop silence. Actually, no Africa, but pin drop silence. And like obviously, like mouth was open of people and everything. And said, okay, just wait a minute. And he went out and he came in 2-3 minutes basically. And back then, like 30 rupees का KitKat का एक बहुत बड़ा box आता था. Today, a KitKat would cost I think 10 rupees for just a small piece. Back then, I think 5 rupees में 2-3 KitKats आ जाते थे उसमें. फिर 30 का पूरा box KitKat का box and he gave me that and he was like, good job done. And then the claps I heard. But anyway, so the answer is the story is very close to me, because like I said, I would like to mark it as the career of mine as a teacher. But anyway, so the answer which I understood it back then was something like, see, when Niebuhr came with this theory, back then his period, mostly periodic table was not available. Now we know there are 116, 118, 126. That is what last I heard are the number of elements. But back then I think he had only Mendeleev's periodic table and we had only 63 elements odd, which was known to him. Probably basically less number of elements were known to him in his period. And there were many missing pieces in the periodic table. Like this element was missing, that was missing, this was missing. Okay. So the lowest element that he knew was hydrogen. But he was worried. See, if hydrogen shell that I have, if I give it A shell, what if in future we find a smaller atom whose orbit is beneath the K shell, like lower than K shell? What if that is L shell? Like, sorry, if I name this as A shell, if I name this as A shell, then what will I name the lower orbit? Minus A. That doesn't sound good enough. But then SSO, you will always get stuff. Like the point is, if hydrogen atom is A, what if he finds another atom in future whose orbit is beneath the hydrogen atom? He cannot call it minus A, and then it becomes such confusion. What if there is another atom that is found? What if there is another atom found? So that way, though, he thought that he shouldn't even give alphabets. But then he realized even if he gives numbers, it is always a possibility that you can find a smaller orbit than hydrogen's orbit. But then he thought what to do. Then he thought about planetary systems. The planet, the Kepler's law and gravitation, Newton's law, everything that was already ready. So he realized that what if there is an APGP progression? Just like electrons orbit around the nucleus for stability. One thing was clear: electrons cannot enter the nucleus. So if this is first shell, after some distance you have second shell, after some distance you have third shell, after some distance you have fourth shell. People, if I give you some numbers for an example, this one, right? If I give you some numbers like this, sorry, not this board. If I give you some numbers like, right? I know, screen sharing. If I give you numbers like, let's say 11, then 13, then 15. Like suppose you find out that 11 is, let's say, right now the distance of the first shell, then you would know that 13 would be the next.
Hello. Hello, sir.
Okay.
Hello, sir.
I am
Yes.
working in the darkness. The electricity is went away, but I hope I'm audible and I'm ready to passport.
Yes.
Yes, sir.
Audible? Okay. You can tell my voice breaks. I
Yes,
was
sir.
saying,
Please slowly.
so if I give you an APGP, okay. So if I give you an APGP progression, like 11, 13, 15, 17, just like you can go forward, now you know how to go backwards as well. This is 9, this should be 7, this should be 5, this should be 3, this should be 2, sorry, 1. But now you cannot go because you're prohibited to go beyond this. You cannot enter the nucleus. So that's what he did. He worked on APGP theory, and he found out a relationship which was identical to the planetary relationship also. Identical to planetary. And he found out at maximum, if at all lower orbits exist, if at all they exist, then at maximum around 9 orbits can exist. But then also, he thought if at all there is an error here and there, at maximum only 10 orbits can exist lower than lower than hydrogen's orbit. Beyond that, electron enter the nucleus, so we cannot have more orbits. And hence he skipped the first 10 letters A, B, C, D, E, F, G, H, I, J, and he gave it K. Like that.
अरे वाह.
Okay, nice. So
Nice.
a very decent, simple answer to this, a beautiful answer, but not given in the books. You have to read it out. Okay, but yes, a beautiful story to this. And then obviously I got the ticket after this. Okay. Chalo. Anyway, proceeding ahead with this chapter, let me connect to the Wi-Fi. I think Wi-Fi I don't think immediately will be connected, maybe in a couple of minutes. So I hope you understood this, people. Hello.
So especially the Niels Bohr named them these things.
Yes, Neebo. And hence he gave it K shell, basically.
Okay.
Yes. So basically a nice answer, very beautiful answer, but again, people need to ask these questions. It might sound silly at the beginning, but then it's okay, keep asking. And these are the kind of questions, like once I got an answer to this question, since then I have started asking questions like anything, especially with the nomenclatures, and I've tried to impart that thing also in your head. And I think for forever, now you will always be suspicious of the nomenclatures. Why does it not like this? Why does it not like that? Anyway, chalo, next. Let me reconnect to the Wi-Fi because I don't know the subject. Okay, people, I'm reconnected to the Wi-Fi. I'm audible.
Yes.
Yes.
Sir.
Okay, chalo, let's continue. So people, what is D generacy with spin? 2n square. I mentioned D generacy with spin. D generacy of hydrogen atom with spin. Okay. Basically for fermions. For spinless fermions, it would be just n square. And it would be n square for you can say spinless fermions. That's fine. Chalo, next. So this is understood. And like I said, one kind of question in this that could be asked is they can ask you which of the following is an absurd wave function. And I can give you, for example, psi 21 minus 1, let's say psi 321, let's say psi 323, and let's say psi 310. Okay, which is absurd.
सर हाइड्रोजन एटम के लिए तो डी जनरेसी n स्क्वायर होगी ना?
हाँ, so n square है ना?
ऊपर 2n स्क्वायर.
No, this is with spin we learned that 2 से multiply होगा ना? If you have spin up spin down spin.
तो सर फर्मियंस के लिए है ना वो तो?
हाँ, so अरे hydrogen atom means what if hydrogen atom has electrons?
Okay, सर.
हाँ, it's
Yes,
an atom.
actually, according to the electrons or that means particles.
हाँ, particles. Okay, so for an hydrogen atom, if you take fermions as particles, electrons is fermions basically. You will have 2n square. And if it is spinless fermions, then it will be n square. Clear now?
Clear, sir.
So which is an absurd wave function
The
here?
C is 3 to 3.
Absolutely, no? Okay, sir, क्या चीज़ question पूछकर? ठीक है, but still, okay. ठीक है, people. Ask me if you still have any questions here. No? So it's simple, but first logic should be the first logic. L cannot be greater than n, okay, and m cannot be greater than l. This is the first important logic. So L is less, L is less, L is less, L is less. That's good. M is less, M is less, M is greater. Here only you realize it's a wrong wave function. This is definitely a wrong wave function. So this is an absurd wave function. All the others are valid. Okay, that's good. Sure, next. Proceeding ahead. Now, so hydrogen atom kind of is done, but I want to take a couple of questions in this. Okay. So people, what was the ground state wave function? Psi 100 for hydrogen atom. Actually, I'm not giving you that. So that you have to note now. Only wave function that you have to by heart, people, for hydrogen atom is the ground state wave function. No other wave function you have to by heart. For harmonic oscillator also you have by heart. That was A e raised to minus alpha square x square by 2. Alpha was m omega. Alpha square was m omega upon h square. Something like that. Okay. So that was for harmonic oscillator. For hydrogen atom, I need you to by heart the ground state wave function. Ground state wave function. Please by heart psi 100. This is given by 1 upon root of pi a naught cube into e raised to minus r upon a naught equal. That's it. And what is a naught? A naught is Bohr radius. Huh?
Bohr radius.
Yes. Bohr radius means radius for n equals to 1 orbit, for ground orbit. I think 0.53 angstroms. as far as I
0.53 angstrom. Yes.
Yes, sir.
0.53 angstroms. So that is basically radius of hydrogen atom for ground state. Okay. So please by heart the ground state wave function. No other wave function you are expected to by heart. Okay. Sure. We can take a question here for an example. Find expectation value of position for this ground state. Okay. Let's do that. Let's take a question. Find. Actually, this is already normalized, if you realize. I could have not given you, I could have just given you this, and you can take a question here if you want. Like, try this for your reference later. You can take a question. Suppose if I would give you that wave function is just a e raised to minus r upon a naught. You need to find the value of a. So how you will find normalization? Answer should be this. Do this. It's a good practice. You will use normalization. And I've already told you the rule for normalization. You will use psi star psi, but you will not write dx, not dr. You have to write 4 pi r square dr. Okay, that will be 1, and r will go from 0 to r.
Here A naught.
Sorry, 0 to infinity. Pardon?
I was asking the upper limit should be till A naught because the ground state ना, तो वहाँ तक तो जाएगा वो. हमारा wave function तो first shell में limit है ना उसकी.
Now I'm also thinking. But then question also lies that it should be a naught, because if we don't write a naught, then how will we get a naught? No, but a naught is already there in the wave function e raised to minus r upon a naught. So
Integration के बाद ये जो अंदर आना चाहिए ना पर.
integration के बाद isn't कहाँ पे यहाँ पे ऊपर?
नहीं, I mean I'm just confused with the upper limit.
Wait, I'm confused. I'm not sure what you're asking.
I was asking that we are supposed to get the normalization for ground state.
Yes,
Till ground state, no?
yes.
And ground state is limited till k shell, that is n equal to 1.
Okay.
Yeah. So the radius that I must take for that should be equal to Bohr radius, or should we go to infinity? That is my confusion.
See, now again, that's a question that is confusing me too at the moment. But I'm thinking that if we write a naught, and if we write 0 to a naught, and if we write 0 to infinity, 0 to a naught would also mean what? Like, this is, we are calculating psi star psi, which is equal to 1. This is probability of finding the particle basically when we write 0 psi star psi, right? So this is probability of finding the particle. Actually, this is not the concept of Bohr orbit. This is the concept of probability of finding the particle from 0 to infinity. This is probability, right? This is not radius. When you say normalization condition, you say that the total probability of finding the particle, it is 1 in all space.
Yes, sir.
So we are not bounding the particle right now, because the shell is allowed to have K shell, L shell, M shell, N shell, whatever. However, you are not bounding the particle. For example, the thing I think which can explain you this is when we used to solve these questions for 1D box. For 1D box, when you used to write psi star psi, okay, no matter what is the value of psi, the range was equal to that of box, which was always 0 to L if you are using normalization. No?
Yes, sir.
So like, does this depend on the value of the psi star psi, that is a ground, or this is 2, or this is 3? It was independent of this. So which wave function you are considering, that is not important when it comes to the range. Okay, so you are not confining the atom. You are not confining the atom that the atom must be at the ground. The atom can be excited to, it can come back to ground. You are not confining it.
Okay, sir. Got it.
We are not confining it. In box we confine it. We say that particle must exist from 0 to L, and hence it goes from 0 to L. But in this also we have a first excited state, we have a second excited state, we have a ground state, first excited, third excited. We have got all of it. But for all of it, limits always remain from 0 to L. No matter which state, limits always go from 0 to L. Similarly here also, we don't care that which state is this. Limits should always go from 0 to infinity, no matter what. Okay. So do this, people, and if you do this, you will get the value of A. And the value of A it has to come out to this. It's a good practice. It has to come out to this. First you copy this. You will practice this, okay? And you will have to use this gamma function. Please ask me if you still have any question. The point is, this limit, people, this is independent of which energy wave function it is. Okay? This is probability of finding the particle.
सर फिर ए नॉट क्यूब कैसे बनेगा सर?
क्या बोल रहे हो?
ए नॉट क्यूब इसको सोल्व करेंगे जब.
नहीं, मैं नहीं समझ रहा हूँ. क्या बोल रहे हो?
ए नॉट क्यूब सर, ए नॉट क्यूब भी तो आएगा ना आंसर में जब ए निकालेंगे तो.
Sir, psi 100 equal to 1 upon root pi a naught cube.
तो ए नॉट क्यूब सर कैसे आएगा सर अगर नॉर्मलाइजेशन कंडीशन लगाएंगे जब?
आएगा ना, क्यों नहीं आएगा? I don't understand what is the question right now. Okay, but I will do one. I will solve this question for you. This question has been confusing.
Yes, sir.
Let's do this. So what do we have? Let's do this. So we have got 0 to infinity of psi star psi. Okay, d 4 pi r square dr. Let's do this for no problem. We have time. This is 1. So this goes from 0 to infinity. So psi star psi. What is psi people? This is psi. A e raised to minus r upon a naught. Now substitute. A e raised to minus r upon a naught. Psi is also a raised to minus r upon a naught because there is no complex term people. So it's fine. 4 pi r square dr. You can throw 4 pi on that side. That's fine. So what do we have? A square. I can throw outside. 0 to infinity of e raised to what do we have? Minus 2r upon a naught people. Okay. You know, r upon a naught. R upon a naught. That's 2r upon a naught people. Okay. You can throw r square also outside. Sorry. You can throw 4 pi also outside. Okay. And we have what? R square dr. This is 1. Okay. A into a square outside. 4 pi outside. E raised to minus r upon a naught. E raised to minus r upon a naught. This is e raised to minus 2r upon a naught. And then we have what? R square dr. Let's calculate further. So 4 pi a square. Now we have to do substitution people here. So let's do substitution. I will say 2r upon a naught. Let's say this is t. So r is 2 a naught t. Okay. So what do we have? I can say dr. This is 2 a naught dt. I hope you have with me. Tell me now. If not,
Yes, sir.
No, sir. A naught t by 2. R equal to A naught t.
Yes, yes. So this is r is a naught t by 2. So dr is a naught dt by 2. Yes, good observation. Next, let's substitute. So we have got 4 pi a square into what about limits? Are they changing? No, right? When r is 0, t is 0. And when r is infinity, t is also infinity. So this goes from 0 to infinity. Okay. E raised to 2r upon a naught. What is 2r upon a naught? That's t. Okay. R square dr. So we have got a naught square t square upon 4. है ना? R is a naught by 2, right? You have got r square dt. So a naught square t square by 4. And then you have got dr. What is dr? A naught dt by 2. This is 1. देखो ना a naught क्यों आ रहा है ना? आ जाएगा, टेंशन मत लो. ठीक है. So what do we
Yes,
have
sir.
people? Okay, 4 gets cancelled here first of all. Okay. Copy this much फटाफट until here. Done people, shall we?
Yes, sir.
Sure.
Yes,
So
sir.
what do we have? Pi a square, okay, into 0 to infinity is equals to a naught cube I'm going outside, okay. Then t square dt, I'm also doing 2 outside, okay. 2 outside. Look, pi a square is outside, a naught into a naught cube is outside, 2 is outside. I've got e raised to minus t square dt, okay. E raised to minus t square dt, okay. This is 1. So we have got a naught cube pi a square upon 2. This becomes 0 to infinity of
Gamma
written like
t
this, right? E raised to minus t square can be written as t raised to 3 minus 1 dt. This is 1. This is the formula people when you write 0 to infinity of e raised to minus x raised to n minus 1 dx. This is gamma n people. So yes, absolutely. This is gamma 3. Okay. So we have got a naught cube pi a square upon 2. This is gamma 3. This is 1. So we have got a naught cube pi a square upon 2. What is gamma 3? 2 factorial people. This is 1. 2 gets cancelled. We have got a naught cube. We have got a square is 1 upon pi a naught cube. आ गया ना यार?
Yes, sir.
1 upon pi a naught cube.
समझ आ गई कहाँ लिमिट कोई चेंज नहीं
हाँ, exactly. No problem.
सर नहीं आता तो कल आप क्लास नहीं ले रहे ना इसलिए टेंशन हो रही
अरे कोई नहीं, so completely fine. I understand. ठीक है. Any questions, anyone?
ठीक है सर.
Chalo.
ठीक है क्लियर हो गया कॉन्सेप्ट
Proceeding ahead. Next. Okay, so let's take the expectation value question, people. I wanted us to find the expectation value of position in the ground state. So expectation value of r cap in the ground state. Okay. So we have how do we find expectation value? Don't write minus infinity to infinity. Okay, remember 0 to infinity. ठीक है. Of psi star
आर
r cap
साइन
साइड dx
Tau.
deta
डी
tau. Denominator भी रहेगा, but that will become 1 because now it's
Normalized.
normalized. Now it's normalized. So you can write if you want 0 to infinity of psi star psi theta, but now we have already normalized it. ठीक है. So this is 0 to infinity of psi star. Psi star is nothing but 1 upon root pi a naught cube. 1 upon root pi a naught cube into e raised to minus r upon a naught. Okay. R cap is r people, just like x cap is x, y cap is y, z cap is z. R cap is r. Psi is 1 upon root pi a naught cube e raised to minus r upon a naught. Okay. D tau is 4 pi r square dr. Denominator is 1 because it is already normalized. Copy this much. Yeah. So what do we have? This becomes 0 to infinity. Let's throw constants outside first of all. So what can I throw outside? 1 upon root pi a naught cube, 1 upon root pi a naught cube. That goes outside, it becomes 1 upon pi a naught cube first of all. Next. 4 pi, you can throw outside people. I can also throw 4 pi outside. We have got e raised to minus r upon a naught, e raised to minus r upon a naught. That is basically e raised to minus 2r upon a naught. And we have got r into r square dr. We have got r cube dr. Ask me if you have any questions until here. Okay. So pi gets, we have got 4 upon a naught cube into 0 to infinity. Again, I can go with substitution. So we have got 2r upon a naught as t. So r is a naught t by 2. So dr is a naught dt by 2. Let's substitute. Again, limits remain unchanged. R is 0, t is 0, r is infinity, t is infinity. Okay. E raised to 2r upon a naught people. This becomes t. R cube, that becomes a naught cube t cube by 8 because r is this. So r cube becomes a naught cube t cube by 8. Dr becomes a naught dt by 2. Let's cancel a few things immediately. A naught cube gets cancelled. Okay. We have got 4 ones are 4 twos are. I can throw some constants outside. A naught you can throw outside. 2 twos are 4 you can throw outside. We have got 0 to infinity of e raised to minus t cube dt. People t cube can be written as basically t raised to 4 minus 1. And t raised to 4 minus 1, that's nothing but gamma 4. This is a gamma function. So that's gamma 4 people. So we have got e naught by 4, gamma 4. Okay. So we have got e naught by 4. What is gamma 4? 4 into 3 into 2 into 1. And we have got 4 gets
4
cancelled.
नहीं आएगा सर
Gamma 4 is 3 factorial.
n minus 1
Gamma 4 is 3 factorial, right? So this is actually a naught by 4. And you write 3 factorial, that's 3 into 2. So that's 2 ones are 2 twos are. Our expectation value is 3 a naught by 2 people. Expectation value is 3 a naught by 2. Make a note, please.
so the probability is maximum at this distance
At 3 a naught by 2. Okay. Make a note, please. That's correct.
Yes, sir.
Okay. People have copied this?
yes sir
Another important thing. So see, the ground state wave function for hydrogen atom we have written is 1 upon root pi a naught cube into e raised to minus r upon a naught. Okay, just a minute. So I'm going to write this as 1 upon root pi into 1 upon root a naught cube e raised to minus r upon a naught. So this is also nothing but 1 upon root pi. I can write it as 1 upon a naught the whole raised to 3 by 2. Tell me if you have any problem with that. The root means half now. Okay, so root means half means e raised to 3 by 2. You can write this. Understand when you write bx root of x raised to a, this is actually x raised to a by b. So when you write square root of a naught cube, so that's actually a naught raised to 3 by 2. In that sense, nothing else. And 1 raised to 3 by 2 is 1, right? 1 raised to anything is 1, so don't worry about it. 1 raised to anything is always 1 anyway. Now the thing is, this is only for hydrogen atom. That's what I've been telling all the time. Okay, this is only for hydrogen. That's what I have been telling all the time. I actually said telling, just like a proper picture. Okay, but for hydrogen-like atoms, Z will come into picture. Okay, and psi 100 for hydrogen-like atoms becomes equal 1 upon root pi into Z upon a naught raised to 3 by 2 into e raised to minus ZR upon a naught. Make note, please. Okay, people, what is the value of Z for hydrogen? 1.
1.
So if you put Z, are you getting hydrogen back?
Yes, sir.
But now, without solving, scratch your head and shortcut, use a shortcut logical method. Tell me what would be the answer of this average expectation value for an H-like atom. People, take your time. For hydrogen, you learned it's 3 a naught by 2. You don't need to solve. You can use just a small trick and identify what will be this for hydrogen like atom.
A naught by Z.
But a naught by Z. The thing is, people, you can take this like Z upon a naught. Like you can substitute say Z upon a naught is actually a naught. It's like you have replaced 1 upon a naught with Z upon a naught. All you have done here, you have replaced 1 upon a naught with Z upon a naught. Here also you have replaced 1 upon a naught with Z upon a naught. Z is a constant, right? So just like a naught was constant, Z is also constant. So all you have done is what you have done here, replacing 1 upon a naught with Z upon a naught. Here also look at this, replacing 1 upon a naught with Z upon a naught. So the point is, we have replaced 1 upon a naught with Z upon a naught. It means you have to replace a naught with a naught by Z. Analogy. So your answer will be 3 a naught. Replace a naught with a naught by Z. It will be 3 a naught upon 2Z. That's it. Okay, because Z is anyway constant. It's like substitute Z upon a naught as P naught, people, like 1 upon P naught. So throughout your integration, you will have P naught, there also you will have P naught, everywhere you will have P naught, people. And then you will again replace that P naught with a naught by Z. Once again. Tell me if you have any questions. Have you understood this analogy idea?
Yes, sir.
Yes, sir.
Ask me if not, okay? All you have done is replacing 1 upon a naught with Z upon a naught. First, here also 1 upon a naught with Z upon a naught. So again, we will do 1 upon a naught with Z upon a naught, reciprocal. A naught is a naught by Z, so a naught will be a naught by Z. And one question which you will solve for your practice, I have calculated for R now. I want you to calculate for R square. What will be the change? Here we will have R square now. First, okay? We'll calculate it. Answer will come out to be equal. Okay? Average value of R square for hydrogen atom is just 3 a naught square, people. Just 3 a naught square for hydrogen atom. Now, what will be the answer for hydrogen like atom?
So Z square.
A naught by Z square.
Z square.
So a naught ki jagah you have to write a naught by Z. So this becomes 3 a naught square upon Z square. You will solve this for your practice now. Okay? So this is it, people. With this, we complete our quantum mechanics. And tell me, as a investor, you don't have to tell me, I know this and we know this, that the way you imagined quantum mechanics 1.5 months ago, what is the transition like? I say you don't have to tell me, I already know the answer.
It's really exciting.
It's very exciting, and it's not
सर
difficult.
क्लासिकल से ज्यादा मजा आया इसमें
I know, but
क्लासिकल हाल
Okay,
लगा
okay. हो सकता है, absolutely. Both the subjects are very scoring people in exam, very scoring. Both of them have got good weightage, 15 to 20 marks from each. So it's like even if you want to do these two subjects all the two nights, for the qualification you get an 90, you will end up getting about 30 marks only from these two subjects easily. Okay. But anyway, so regarding your exams, if you need to ask something, if you want to discuss something, you can discuss that now. Otherwise, our syllabus is done, our journey is done, and I had a very, very, very great outstanding time teaching with you all here. And in fact, I'm already looking forward. I already told that I'm extending my contract with this server. I don't mind repeating another year with it, so I will be here even for the next batch too. But so if those who are anyway in the second year and first year, I will be with you again for another year. I'm not sure if you will be there in the live lectures or not, but either way, you are still a part of it, so we can always have a conversation. And beyond that, beyond the exam, also people you all can always stay in touch. So that's their social media is anyway there, so that's not a concern, that's not a problem. And regarding your exam, listen, what my aim was, that's what I have completed. I'm giving you one complete month, people, and listen to this very carefully. What should be your plan like? That's what I feel. For all the others who have not yet started with the mock test, especially today's 13th. Literally, people, from tomorrow onwards, you have to give 3 days to 1 volume each, and you don't have to do anything else. 16th, you have to give 1 mock test of classical. You arrange the mock test, people. 19th, you have to give second. 22nd, you will give third. 25th, you will give fourth. 28th, you will give fifth. 31st, and third. Do your calculation, people. 16, 19, 22, 25th, first, and fourth. So by 4th of February, or by 5th of February maximum, the 7 volumes should be done. 3 days each for 1 volume. That should be 3 complete days when you have the whole 24 hours things. I'm not sure how many of you have college commitments, but please prepare every volume each day. Now, don't take any new topics, don't learn any new extra things. Just give your complete dedication to 1 volume each. And once your 4th Feb is reached, 5th Feb is reached, and after that you can you can practice more and more full-length volume tests from 5th to 10th. You can find many books also available on the internet which provide volume-wise tests too, and full-length tests too. After papers are also already available, but practice. And I will suggest don't do anything new. Literally 1 volume. Remember, people, I personally have given jump 3 times. I have told you this. Forget my preparation, but at the same time, I have met more than 500 to 1,000 students in my 3 years of preparation, and I've been teaching jump for 2 years already. So I literally understand what needs to be done for this exam. If you are going to stretch, if you are going to run behind completing the syllabus now, people, that will be at the cost of your marks in exam. You need to trust me here. You need to believe me here. Don't rush behind completing the syllabus now. Now just ensure that whatever you have done it so do it so nicely that you keep a full stop in that chapter. You cannot leave a comma. You cannot just leave a comma. You have to ensure that you have to complete everything neatly and nicely. Tonight, like after we are done with the class, whatever extra you want to do now, do it today. Like this topic, that topic, here and there, whatever you have scattered, do it only tonight. But once you wake up tomorrow, you have to dedicate yourself for 3 days complete for 1 volume, people. and 7 volumes must be done by 4th or 5th of February. That way only your marks will be like skyrocketing. Whatever is your potential now, you will push yourself to your maximum of your levels. That's one thing. Next, giving tests becomes important. At the same time, analyzing the test becomes more important. If you give a test, a volume test, or mock test, or whatever, 3 hours of test giving is fine. That will teach you patience. Like skipping a question is also an art, people. Many times, many students who don't practice tests, who directly give jam, they get the panic attack in the jam itself. Like in a way, suppose at a stretch, you are not able to solve 4th question, 5th question, 6th question, 7th question, and now you take it on your ego. Like, yeah, 4th question, you are pura saal mehnat kiya, now what to do? I've done so much of hard work. And the next question, even though it's difficult or whatever, you will insist yourself in solving that question. No, people. And this mentality of skipping the question or trusting yourself, it's okay, I've got 60 questions to deal with. Remember, at the end, none of you need to score 100 or 100. You don't even need to score 90. You don't even need to score 80. If you score that, it's outstanding, but you don't need to score that much. If all of you are aiming for the 3 IITs, people, if you have 1 IIT, then that's very precise. If you have 5 IITs, in your mind, the 3 of all IITs, all you need is a score more than 50% syllabus. Complete 60-75% syllabus also nicely, that's sufficient. Your target should not be to solve all the 60 questions in 180 minutes. But you need to ensure that you at least go through all the 60 questions within 120 minutes. The reason is, many times what will happen, this happened recently, I had a conversation with a student, and the person spent 2.5 hours in solving MCQ section. And then the person has left questions like degeneracy of 1D, 2D boxing in 80 sessions because the person even did not know that that question exists there. So your strategy, the most important strategy that you should have here is that once you start with the paper, okay, you first have to complete 1 round of the 60 questions in just 1 hour or 1.5 hours. Basically, what you do, you see the first question, you know you can solve it, but you know that it is going to take time. Skip it, just go through the second question, go through the third question. The point is, you'll first attempt those questions from 1 to 60 which you can do it like that, like your by heart. For example, if there's a question eigenvalue, do it then and there. If there's a question degeneracy, do it then and there. If you find very seriously small questions now, first you will complete that so that you won't have the regret at the end that I left those silly questions. And then you come back and solve. So basically that way, again, your marks will be improved. And remember, you have got 180 minutes, you have got 60 questions, per question you have got 3 minutes. Don't be rigid. You cannot take ego here with yourself. Even when, there will be questions which are known as speed breaker questions. Like for example, let's say they are giving you
text analysis
question, or whatever. Suppose text analysis where they're asking whole moment of inertial tensor to find. Or Fourier series where they're asking you to find the whole coefficients, like find A and find B and find D. Even though you know how to solve it, you should not be solving it in that moment, because that will consume 5 to 6 minutes. Temporarily skip it. Go ahead and first complete the question which can be completed in that 3 hours frame. And then if you have some time, come back to that question. Okay. So basically this art of how to deal with the paper, that can be done if you have had enough practice. So prepare for 3 days, 1 volume, give a volume test on 16, give a volume test on 19, but prepare like this and practice people as much as possible. That's really important. And what else? I don't want anybody here to leave any question in MSQ or NAT. People MSQ and NAT don't have negative marking. And JAM is not going to give you like they're not going to select you on the basis of your accuracy. They're purely going to select you on the basis of your rank. So in MCQ you have negative marking. In MSQ and NAT you don't have negative marking. So those 30 questions you don't know or you don't know, you have to mark. In MSQ, for example, if you have 1 to 10 questions, okay. So in those 10 questions, suppose you are able to solve 6, 7 questions logically with your head, or 8 questions you have done, but 2 questions you have no idea whatsoever about. You don't know what to do there. So mark something randomly, like mark B, C, D, mark A, D, or just be more realistic. Use a probability idea. They tell you when if you will set a paper on JAM, and if you are going to set this MSQ section, don't you think you will ensure that all the 10 questions at least there shouldn't be too many ABCD, there shouldn't be too many ABC. You will try to ensure one is ABCD, one is ABCD, one is ABCD, one is ABCD, other is CD. So you will try to scatter those probability. You cannot have 4 questions which are ABC, ABC, ABC. You cannot have that. So the point is, in that 10 questions, if you have done 7, 8 questions, and none of them was ABCD, or none of them was, let's say, AD combination or BC combination, which you feel is a common combination, then in the remaining 2 questions which you have no idea about, mark BD in both of them. Mark ABCD in both of them. That your chances of getting those free 2 marks, that will increase. In NAT section, for example, there is a question, they're asking you angle. You don't know how to solve. Like fluke 30 degree, 45 degree, 60, 90. For example, if they mention write the angle in variance, okay, and in the bracket you have written approximate the answer to 2 decimals. Use logic. For example, it could be pi. What if it is 180 degree pi? Pi is 3.142. So write 3.14. The point is use some common sense, but write NAT. Don't leave it. Write 0 somewhere, write 1 somewhere. Whatever numbers they have given, play with the numbers and put. And always remember dimensional analysis could be a very important factor in your MCQ, your NAT. There could be an MCQ where they're asking you which of the following equations is correct, people. And if they're asking you equation, then if all the equations have a different dimensions, it's evident. Like suppose one is f lambda, one is f by lambda, one is f square lambda square, one is f upon lambda cube. If all of them have a different dimensions, see what is it that they're asking. If they're asking speed, check which one of them is correct dimensionally marked. I don't want to go behind the physics. Best part about entrance is nobody is going to ask you how you got the marks. The most thing that is going to be important is you got the marks. And remember, 15,000 plus questions plus students are going to be present in this exam. 100 marks, 15,000 students. 1 mark, 150 students. If you increase your marks by 2 or 4, even with the help of these little tricks and techniques, your rank will jump by 150, 300, 450, 600. The point is, be smart, do not be rigid, practice, stay calm, and if possible, also try to give all the mock tests if you are trying to give in JAM time frame. Try to give from 9:30 to 12:30. If you have college, I understand you can shuffle your timings accordingly. But for all the others, I will suggest you to give the JAM examinations of mock test examinations from 9:30 to 12:30. What will happen? It's a psychological advantage. Every day, it's like you have a test. If you solve 10, 15 mock tests from 9:30 to 12:30, JAM will be like more other exam you have done. So it builds you psychologically also that way. And sleep well. Most importantly, please, this is something which I have done, but I don't recommend. Do not stay awake, on the night of the JAM examination. If your center is away, from your house, travel there a day before. Okay? Travel there a day before. Just stay in some hotel or your room or wherever. But sleep very nicely. Like sleep. And remember, if you're thinking, so I will go to sleep at 10, I will have 7 hours to sleep. That's good. Do you really think if you're going to go to sleep at 10 on the day before JAM, you'll get the sleep at 10? Your mind will be thinking continuously. It will take 1.5 or 2 hours at a stretch for you to get the sleep because you have an exam. You know that. So you need to jump to the bed by 9 o'clock. I will suggest. You can do one thing with yourself. You can stay awake the secondary night. Like for example, 13th you have exam. 11th you have that way, what will happen automatically on 11th evening, you will want to sleep back, and that you can sleep very nicely. And next on the day of JAM, you will be all fresh, open up, like every nerve of your brain, that will be pulsating with energy, people. But sleep is very important, especially on the day before the day of the exam. Do that and take care. What else? All the very best. And no matter what, remember, getting into IITs is a luxury, not a compulsion. It's only a luxury, people. Okay? Bye. Thank you so much.
Thanks a lot, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Miss you, sir.
Thanks a lot, sir.
No problem.
We miss you, sir.
Arey, same. Chalo. Okay, people. No
Thank you,
problem.
sir.
No problem.
Thank you, sir.
No problem. Chalo, see you people in the meeting. Thank you so much. I'll end the session.